very excited. We have a panel of judges here from the Dynamo Refinery teams. We have Saul Moore, who's a PM of Dynamo. We have Zach Cron, who is the product line manager of all of our different generative design products. We have the product owner and lead software developer for Dynamo, and Mike Kirshner. We have me, I'm Michelle Williams. I'm the AI development manager for our group. And we have Radu Gide, who is a good friend of ours from Instoa. He's one of our consultants and did the training for us on the first half day. He's amazing, one of our biggest power users. So I think without further ado, we are going to kick off our presentations. They should take about 45 minutes. The team will then deliberate for about 30 to 45 minutes while Zach will give you guys a really great presentation on what the group is doing and all sort of a few things about what to look out for. Yeah, he might even do a little dancing. Oh, okay, no dancing. All right, so while we kind of deliberate on that, you'll get a nice little presentation, and then after that we'll have awards, probably around 4:30, 4:45, and then afterwards, around 5 o'clock, we'll have our social hour. So beer, pastries, cake, all that kind of stuff to get to know each other. So thank you guys once again for coming out. We are so happy for you to join us. We hope you had a really fun time, and we're really excited to see what you've got. So without further ado, let's kick off with our first presenter.
All right, so Turner Fleischer's Automation Nation is happy to present our new weapons, the shade thrower. So you see, buildings could be quite big bullies in the communities. They can throw shade on our cherished open spaces, our parks, and our backyards. So this new tool that we'll be developing will try to keep these bad boys in check. So the objective that we were trying to do was to evaluate shadows against municipal standards. In addition to these tests, to minimize shadowing on park spaces, and while maximizing height and in turn gross floor area. We broke down our project into 3 phases, leveraging different tools along the way.
So initially we created 2 macros in Revit. The first macro was extracting the vectors of the sun direction from various views set up in Revit. We used a function that was developed by Jeremy Tymick, who was a programmer at Autodesk, and we used this function as well in our internal tool for shadows. The second macro that we developed, gets all the coordinates of filled regions within Revit, which are essentially annotation shapes, and exports it to a text file where we then use them in Dynamo to create shapes from those coordinates.
So from there, we took those the information we got from those macros into a text file that we imported into Dynamo, and we used them to well, first we used the vectors to project a surface from the mass of a building that we made in Dynamo. And we also used the surfaces from the park areas and different shadow areas to project those shadows onto to get each different time that we needed to test. And compare it with the areas that we needed to control.
We also created some simple zero-touch nodes that get the results into areas, and basically spits out a score based on how much that area is covering a specific zone. So for example, if an area is covering a zone too much, it'll get a lower score than an area that doesn't do so.
1 minute.
So this is the look at the final script utilizing the different methods that we discussed. So the rules that we used were from the city of Mississauga, and they're looking to protect private spaces through these things called null impact zones, where shading can occur in 2 consecutive test times, but also looking to protect public spaces by limiting shading across all test times to less than 50% of the area of the space, or allowing full sunlight at half the test times. This is the setup that we were using to test it, and then we pushed it into refinery to maximize height and optimize the orientation sighting on the site area. And so essentially what we have right now is a building envelope that's allowed.
Very nice.
So you're asking where the sun information is coming from? Yeah. So they're set in Revit, and we extracted the information from Revit using the macros.
Thank you, guys.
Hi everybody here, and hi everybody who's watching us on streaming. We're happy to introduce you to what we developed during this 2-day Toronto Hackathon. This is our team, last minute team. So Simon, Yana, and Mercedes. I would like to introduce you to our 4 team members, Sarah, the French painter who was known for pointillism. He couldn't make it, so we decided to name our Dynamo extension after him. So picture yourself doing a massing study in refinery. You got your inputs, you got your outputs and your constraints, and then your scattering plot start populating after you run your first run. Similarly, your parallel coordinate plots start populating size, but you get to an amount of complexity in which data gets so big that it gets very difficult for you to analyze what options you have. So so the result evaluation you get, it's a 2x one, and then if you got multiple parameters, you can only input 2. And in a real case scenario, you're more likely to have more parameters than 2. So what if the visualization we get shows more than only 2 dimensions simultaneously, even more than 3, meaning we wouldn't have to stick to the 3-dimensional perception space.
Okay, so why we want to do it? So we want to work on the communication between the algorithm and the user. So it actually it allows the user to fully understand the complex result. So yeah, we want to allow the user to fully use the benefits of the algorithm. So to visualize that more in a clear way that can understand. And to do that, we take the refinery results. We run 2 machine learning algorithms that organize our data, and we present it in a 2D and 3D space. Okay, so first algorithm is DISNey, which is dimensionality reduction algorithm. So to clearly to explain the math behind it, the input is a set of vectors. So one refinery result, if it has 10 parameters, is a 10-dimensional vector. We feed those vectors and Tesla run the transformations of the vectors to find the fading representation of the 10 dimensions in within the 3 numbers. So we reduce 10 dimensions to the 3 dimensions. The second algorithm is a k-means clustering. So basically, if we have 200 refinery results, how we can group them into the 5 groups. So within the 1 group, we get only the most similar results. So those are the 2 algorithms that we used, and now there is a demo that we recorded. Yeah, that we recorded.
No, it's live. It's live.
So here's the extension where you select the view, the run that you want to visualize, and here you see various plots. So on the top you have the 2D dimensional reduction. On the bottom you have the 3D dimensional reduction. You can rotate the 3D. You can select the points, and on the right you can see the more detailed information about the particular run. So all the metrics and so on. On the top right, there's averages for the different clusters. So when we cluster it, we do for each of the raw metrics that were evaluated for the graph. Here we're just zoomed in into some area of the 2D version of the runs, and then selected it. It doesn't really do anything when you select it right now, but in the future it will. Everything's on GitHub. In fact, we already pushed it to Dynamo Package Manager. So if you search for it, you can try it out. So if you're running with Refinery, you can use it. Time.
Yeah. Thank you.
It's the best thing ever.
What are the next steps? What are you hoping?
Well, there's a lot of different interactions that can be added where you can explore the data more. Also, right now, it's just generates an HTML report rather than being built into Dynamo extension. The extension really only lets you select the run. Ideally, it would be within it, so you don't have to then switch. And it would be, when you select things, you can have a better connection to the actual graph, just like Refinery. However, maybe next step is to have it within Refinery.
Yeah, cool. Okay, everybody. Thank you, guys.
Okay, hello everyone. So we're MJMA, an architecture firm, and we've called ourselves Good Lucks because we thought we needed it. And so today we're here to study the roof and wall of design for a pool and a gym. And this is an actual project in Toronto that we're working on in the office, and we thought we'd use this opportunity to analyze it and optimize for the following goals. So we want a low U value on the roof and the walls to maximize our daylight factor, to maximize the roof area for photovoltaic panels. It is a net zero project, so we will have PV on the roof. Maximize views through the pool and into the gym. And we want to economize a structural system. So we're here with another team who's going to be talking about that next. Our outputs were very clear. Oh, sorry, another goal we had was to evaluate this workflow with other workflows that we have in the office. This is really a viable design tool for other projects and to use again. So our outputs are, we tried to keep them very clear so we didn't get lost in this process. So a window to wall ratio, the skylight to roof ratio, the number of PV we can fit on the panels. We want to maximize that, and then the number of views through the pool and into the gym. So we did our analysis. Well, we wrote a Dynamo script, and we used a few packages: the Honeybee package, Lunchbox, and Ladybug. Did we use it?
Ladybug, yeah.
Yes, Ladybug. So this is our script. We broke it apart amongst the team. There was lots of like stitching things back together, and we had our clear inputs and our clear outputs. I don't think we have time to go through that. So when we were in Dynamo, we did our analysis. So we wanted to maximize our even amount of daylight in both the pool and the gym. It's very important for the activities that take place in those spaces. So yellow was good. Red, not good. Blue, also not good. It was okay. And then the views through, this is showing us how many views we can actually get into and through the pool. So we had activities on the other side of the building that we wanted everyone to see, so that was a design criteria that was identified by the team. And of course, we want to optimize. So we pushed all of that into Refinery. And that was good, except that we found that, Refinery gave us some options where we didn't have a roof or a wall. So we had to go back to the script and say, hey, we always have to have a wall or we always have to have a roof. And we refined and fine-tuned our constraints. So that was good. So we went back to Refinery, lots of back and forth here, and actually here we found that we could maximize for our daylight, which was what we were trying to really achieve. That was our main goal. And then we had what we considered to be aesthetically pleasing failures that we named and we talked a lot about, and whether they have the opportunity for structure is questionable for some of them. And then our lessons learned was that in Dynamo, custom nodes would have been easier for collaboration. We did not do that. And communication about like inputs and outputs would have been good. Much more communication about that. Refinery, we need to manage our constraints better for better results and limit our outputs. We think we went a bit overboard with our all of our parameters. And then lots of discussion about how this is going to fit in with the larger workflow and other programs that we're using. That's it.
That's it.
Questions? Oh, questions? Questions? Yes, we did talk about that, and we actually asked for Dynamo team to put back the presets functionality. Yeah, so we talked about that because how are we gonna, we found that there were some refinery options that we liked, but then once you close refinery, felt like we lost them or we lost track of them. So because we ran the studies over and over, we found that we actually lost track of some of the options that we liked. So if you could put that back in, it'd be great. I think the jury's still out. We wanted to take reflect on our time. But I think that it's good. I think actually the last ones, the last 6 that we had, or 8 that were on the last sheet, were represented options that we probably would have never come up with on our own, and that's what we were looking for. So with the exception of one, I think the cheese grater was kind of something that we had already had in the office, but some of the other ones were things that we wouldn't have ever come up with organically, manually. Yes, we're going to continue the exploration. All right, any other questions? Okay.
I do have a comment about presets. Mike Kirshner, were you not the one who made those? Yeah, he can put them back in for you, if that is something. And Zach was the one who killed it. Cool. Okay, next up, Blackwell MJMA to the 3rd power.
Do I just control it like this? Nice. Okay. Hello, we are, for this event, MGMA3, but professionally we are known as Blackwell Structural Engineers. We are a real-life plugin for MGMA. Right now we operate on a pay-per-use basis, but maybe in the future it will be subscription-based. So structure is approximately 1/4 of the cost of the total cost of any build. And for this project, we are looking at optimizing the previous scheme that you saw, and we were thankfully given this precedent image to work off of. And looking at this image, the space looks very nice. You can see the effect of the light and the wood working quite well, and also the lighting. The artificial lights probably help as well. But what you cannot see is the structure. So we have determined actually from that photo that the structure does not add any value to the space, and therefore the optimal solution is the cheapest one. So because if you look on the left side, when we increase the cost of the structure, the overall cost of the building pretty much has to maintain the same. So we just lose value in the architecture, which, when the structure gets more expensive, or when the structure is balanced, Blackwell is happy. But when the structure gets more expensive, Blackwell is in fact probably still okay, but we should be unhappy. So looking more into that design precedent, we can see that there's clear spaces for our structure to fit in. And in case you can't see it, we've highlighted it several times. And then the scheme that we have here is glulam beams that we're optimizing here today is NLT deck, glulam beams on glulam columns, and then skylights would be placed between them in several ways. And the way that our script considers this is we just design a gravity load system. Perhaps in the future, we will look to add some lateral capabilities, but for now, it is a gravity load system. So Jordan's going to talk quickly here on how we translated some of those important parameters into our script. So if you could highlight just a couple of them.
Yeah, we were concerned with where we could put a beam and where we could not put a beam. So we needed to latch on a fairly early point with MGMA's skylight geometry. So you can see that's a fairly reasonable analog of the skylight sketch that they had before. And that's about it. We had to establish a name for all these variables because we were feeding them in and out of C# scripts, but I guess we'll get into that in short order.
So this is a shot of our overall graph, but we like to focus on a few of these nodes here because these are custom C# nodes. One group here is our column and beam selector, which Sean will elaborate a little bit more.
Yeah, so we got really excited about zero-touch nodes because it's not something we'd done before in the office. So we dove right in and created some beam analysis nodes and beam designer nodes. So they take the input of the geometry and the spacing and the loading information that we provide, and then they feed the resulting moments and required stiffness to a selector that takes all the section properties from the universe of sections that are available to us and selects the most economical section and feeds that back into the geometry.
Just to quickly comment on this.
Yeah, so then, and then incorporating those beam sections back into the script and taking the geometry layout that we had was quite complex based on the skylight layout. So that would form our challenge for today, also in zero-touch nodes.
And we do have a result which is reasonable. We didn't quite get to the point where we had refinery optimizing that yet, but when we do, it will save a lot of money, but not right now. Thank you. Questions?
Yeah, so the question is, did we have infrastructure going into this with respect to analysis and design? And no. And primary lesson learned would be rely on libraries that probably already exist and don't develop them in a 2-day hackathon.
Yeah, it all seems really simple. Like when you look at it, and you're like, okay, that's a UDL and there's some point loads there, and we all know what the diagrams look like, so it's going to take all of half an hour, right?
Yeah, now write it in C#.
and then suddenly it's a day and a half later. Another question from the back. Cool. Thank you.
Our team is called Forms and Forces, and our project is called Recursive by Nature. You can figure out what that means. Maybe $5 before I explain it. Next slide. Next.
Press down or something.
Nothing?
Awesome. No, that's.
Yeah. Next. Yeah.
Okay. So just press down.
All right. So the problem or the overarching idea that we want to tackle is if you have a project where you have very complicated structure, whether it's architecturally driven or structurally driven, and then you're getting into, let's say, complex geometry and then fabrication and manufacturing of it. It's extremely difficult to do that with the current programs that are out in the market. And just because the workflow is so siloed, the architectural company is using one program, the structural engineers are using one, the connection guys are using another, and then the guys that are fabricating are using another program. And so data that's being sent between that information is being lost, and then to iterate is very time consuming and expensive. That's what we want to kind of just go after. Our inspiration for this, and the kind of case study that we thought of, was large span structures, think like entrances to airports or like large canopies, and then getting into like these nice, I think, which are beautiful steel structures that are exposed and just kind of tree shape, which is very natural, and then that kind of you can optimize for span lengths, and then also kind of just getting the geometry of it and the artistic that works well together. So we started off with just dealing with a single tree, and the idea was that the tree was going to grow by itself using recursion, so the function calls itself a custom Python node or script. And you have different parameters that we were trying to kind of optimize and also that were part of the equation. So if you had basically how many children does one branch have? So over here you got it's always going to 3 branches every single time. Here you have 4 branches. You see the complexity. You can get into like what the degradation is. So is the next branch always half that length, or is it 25% of the length? And then you get into the azimuth and zenith to the angle. So that kind of gives you a more broad shaped tree or more vertical shaped tree. So that was one part of it. And then you get into, well, now we need a forest, continuing that analogy or metaphor. So we want a forest underneath a canopy that's arbitrarily kind of created. And then there you have a canopy, so a complex shape. And then these trees are growing vertically to kind of reach this canopy. And part of the function was the function kind of grows and touches that canopy. Take over. So we wanted to iterate on individual trees and kind of figure out what we like aesthetically. Next. Then we got into basically iterating refinery on what we liked for different styles of canopies and different shapes. And from there, we wanted to really keep pushing the depth of this analysis to using Robot, which is a structural design program. And so we were able to import millions of points or millions of members and data points and design them and kept going and get it up to Revit and then put this into like production. So you could maybe theoretically extend this to steel fabricators and now they have all complex geometry. It's all been designed, full workflow done. So the question was, how close did we get to what we wanted from the outset? I think in many ways we actually did accomplish a lot of it, and in some ways we got a little bit further. Originally we weren't thinking of getting into like robot and structural analysis stuff, and maybe, I think we wanted to get into Revit. But one thing that initially that we did want to do as part of refinery was making the front of the canopy itself, that shape, also be a structural element, and then getting into also that be a part of the equation, and then trying to optimize the canopy shape and try to like maybe minimize for steel costs or something like that. But then that was, I think that would be a pretty huge undertaking. Any other questions? Next steps.
Next step for me is like from different offices. It's actually part of our goal in our company to create generative design. So we have some kind of script that's working already. It's similar to what other things do here. So we do optimizing the space. So we've taken like a Revit architectural structure is our map, and inside of this map we're trying to build our building. And so now the tools I saw here other people do, we can now actually optimize like a C# to make it working faster, like if you're on a refinery to check a lot of variation. Connection with robot it's great, and so because it's one of the software we use in our design. So our next step for me is to optimize the script, maybe convert it not to trees but more normal columns and everything. But this is also great. But this is architectural.
Thank you.
Thank you.
Okay, next up we have Hammer Slammers.
So we're from Hammerschlag and Joffe Consulting Engineers, and we've only been using Dynamo for about a month, so we're pretty new. And the purpose of like this hackathon was for us to find a resolution to automate jobs that are repetitive. Are jobs that are repetitive on like a daily basis for us. So the agenda was to identify a problem, break down that problem, find a resolution, and then basically execute it. And our problem, repetitive tasks. So one of the biggest issues that we have is our scheduling and our family parameters, which I guess would contribute to our scheduling. So at the moment, we create external schedules in Excel, then we put them into AutoCAD, convert to a PDF, convert to an image, and then put it into Revit. Because our families don't have the parameters that we need. For example, one of our families, the one that we tested out in this hackathon, had 43 parameters that we needed for our schedule. So that would then cause a problem with collaborating with our electrical department because they don't have the information they need from our families to schedule in Revit on their end as well. So then they end up creating an external schedule as well, which is not what we're looking for. And so it's not an electrical problem or a mechanical problem. It's a problem with our collaboration as a whole.
And so instead of doing our old method of scheduling, we opted to instead inject parameters and values into our families through Dynamo. It's through pre-made Excel sheets made by our designers. They have all the parameters, they have all of our values. So we begin by extracting info from the Excel files, and then we end by forcing parameters and values into each RFA file. So from here, you see that both these FECU's families have no values in them. So I will be running my script to set up the parameters and inject them with the parameters that we need. Errors are normal. And you can see now we have empty parameters for both of them. Then now we will be running our script to inject these with actual values that work. And they each have their own values, so that therefore they are actually different families.
So how this is important for both the departments is because for the electrical departments, when we get an empty family, then we need to create a placeholder that will have an electrical connection. It will connect to the electrical panel. So if we already have the mechanical family, then it can directly connect to the panel. This is just us trying to figure out how to actually connect to the circuits within the electrical panel. So what we go from here is, this is what an electrical panel looks like. And these lines are not just text, they're actually connections embedded into a family. So for example, if the mechanical team deletes one of the mechanical equipments because it already has a connection to our panel, it will leave the empty space on our panel. So it will save us time to find that placeholder and disconnect it, and then arrange these guys on the panel again.
When we run a graph through the player, it requires the user to input which panel they want to fix. This is because large projects, we have certain panels that we want to look a certain way. So we don't want to change all the panels. When you select the panel, it will check if there's available circuit above, and if so, it will shift the panel up like you see above. Thank you for listening. Do we like Dynamo now? We've been using it for a month. I say yes and no. Love it.
I enjoy it. I really want to start to get to know more about it, learn how to script more, like Python learns.
Yes, a little bit stressful, but I think with some practice, we'll get better and it won't be so bad.
Oh, definitely it saves time. Like we already have some graphs working to find like final schedules on views or revisions or calculate like the airflow within a room to see if we need to place more like ducts. So yeah, it's definitely very useful.
Yeah.
No, thank you.
So the question is how we are going to help our engineers keep track of the parameters. So we have our schedules in Excel right now they're formatted differently. They're not really practical for what we want to do in Dynamo. So we're thinking to revamp those schedules or those templates, and then that way they can just update them and push them to us, and then we will run them in Dynamo.
Cool. Thank you guys.
Thanks.
I think it's
Yeah. Go. Yeah, go.
Okay, guys. So, who can tell me what the difference is between those two right there? Yeah. So what's happened? Quickly. Okay. So you can tell we've removed 2 and we've added 1. So the whole addition and number slider have gone. And now who can spot the difference on this one? Anyone? No?
About 3 hours.
Yeah, okay. So basically, this is that's good. And Michael's going to quickly go through the idea of what we can do.
So we have a lot of engineers working at Arcadis, and it can be a real pain in the when you have a Dynamo script that has to be updated by someone else, and then you get it back and you don't know what has happened. So what we proposed was to make a workflow visual in Dynamo that you can see and track the changes. So added nodes would be green, deleted nodes would be red, changed nodes would be blue, etc.
You can just
So we decided to create a program called Trainwreck, which is basically a view extension where you can open your current workflow in Dynamo and then load a reference graph. So that could basically be the old version of your graph. And then when you lock it into Dynamo, you can use the toggles to see which nodes have been added, which nodes have been deleted. So those were red and green. And you can, of course, unload it and then find another graph if you like.
Yep.
Yeah, sure.
Stretch goals.
Oh, yeah.
Yeah. Okay. So we did want to get a few extra things sorted, but using the C# and everything seemed. At first, when we thought we were going to start it, I thought, oh yeah, it should be fine, and it turned out to be a lot harder to do some of the things, including colouring the nodes, was extremely tricky. So one of the things we wanted to do was show modified and moved changes as well as the added and removed nodes. I'll just go back. And we also wanted to be able to integrate it to Git or SharePoint or other cloud databases and have real-time updates and synced working. So if I delete one, it'll delete one on Lawrence's as well. And then colouring of connectors as well would have been nice to have, and then automate running of the tool through a remote server and basically get an image of what's happened. So, and that would hopefully go. So those are kind of what we want to happen in the future, and we'll probably develop it further as well. And then, do you want to go through this?
Sure.
Yeah.
So the entire point of this was we were improving collaborative workflows in visual programming by developing tools to track changes in Dynamo graphs. The idea of this is to enable multiple developers collaborating on a single Dynamo graph to clearly communicate the changes they're proposing. It assists in replicating changes across a repository of graphs. So we have quite a few graphs that are quite similar, and we would like to be able to easily copy changes between those graphs. So this will enable that. We are looking to provide an overview of the history of changes to a graph. So that's the idea of integrating it into a version control workflow, is you'll be able to see the development of a graph at a time. And the other idea is to give code reviewers the tools they need to know what's changed in a graph so they can quality assure the end product. And that screen turn off. And yeah, so just clearly indicate additions, deletions, modifications that may result from human error, plus quashing bugs before they proliferate.
That's it. do you want to see? Yeah. Where are we? How do we get right back to the top? Hold on. One more. That one?
Yeah.
You see on the bottom bit there, just room. There's one that's not in the group. Go down there.
In fact, I think the mouse is pointing out
there. Yeah, there. I've added a node, and there's also one that's been removed, and that's it. So obviously, with our tool, it would have come up in green and red, so I couldn't see it.
Very nice. Thank you. Any other questions? Oh.
I have an audience question from Jacob Small. He is wondering, does it track changes to DYF as well? Or diff, DYF? Not sure what that means.
The short answer, we have to try. So, I don't know.
I'm not sure what the F is.
Custom nodes.
Oh, okay. No, we haven't looked that far into it. That's one of the stretch goals that we set that we didn't get around to doing, unfortunately.
Great answer, he says.
Great answer. Okay, thanks, guys.
Okay, we're the Pinception team. I'm Kyle Martin. So we started out with this premise of modular buildings. We wanted to see how we could do layouts more efficiently. Why modular? Because it's one type of module or a couple of modules that just get repeated a lot to see how many you can pack into a space. There's a typologic component to it where oftentimes it's a circle shape or C, L, T. There's very repetitive configurations if you look at how a lot of these buildings are laid out. So we went and used the generative toolkit from Instoa, which you can get on GitHub, and we started to explore that for the bin packing approach. So there were some really awesome sample files in there we started to poke through, and we're using the bin packing 2D best sort in order to try to figure out how many modules we can pack into a space. So we created a sample property shape, and then we started to look at the actual module themselves. So what are the different configurations of a single unit, a double unit, other kind of rotated pieces, all that stuff. And we had a set dimension of 10 by 25 feet. The reason why we landed at this was because modules are built with the corridors actually in them. So a single unit has a little piece of corridor on the end. A double loaded module has the corridor down the middle. And this creates some really interesting stacking opportunities of these things. When you look at an actual layout of a typology, you see a donut perhaps, an L or a T, but it's actually easier to break it down into subcomponents or subcompartments as we're calling them. So you can see 3 different configurations here of long tops, short sides, and then even kind of a rotating schema. But when we went to pack this, it didn't really sort that well because these are really regularized shapes and we're trying to cram all these different modules in it. So what if we actually didn't stick to parallel repeated subcompartments, but we analyzed all the different possibility of subcompartments inside of it. So our first task was to actually take the property shape and do a first pass at bin packing to see what different size modular configurations that were driven off those unit and corridor sizes could we create. So we ended up at 27 possible shapes that would pack nicely into our property. And then we looked at the areas of these. They all had dimensions. We gave them key values and all that. So that resulted in stacking pairs of 2 or 3 or 4 different of these 27 pieces. We ended up with 121,000 possible combinations. We filtered everything above 75%, which ended up at 4,700. And then when we did the bin packing, we ended up at almost 800 possibilities. So there's a 90% fit. In a 75% fit, there's almost no room for maneuverability to kind of modify these shapes within the property. So then these also took a long time to run, so we ended up into this kind of endless loop. So we re-sorted it and decided to hit the 50% mark, pulling from the middle of the deck, if you will, which ended up in more results because what was much more efficient to run. So that's what those fits look like. That allows us to look at the data analysis of different shapes and which ones were most commonly used. Then things get really interesting because we go down another level to bin pack. So we looked at the longest, shortest, and area analysis of packing the actual modules inside these subcompartments. This is the data outcome of the thing, and you can see that there's a lot of stuff in the middle target. It's modular, so a lot of regularity in the scatter plot. Longest, shortest, and area, different looks at it. And then this is what a layout would look like because we're essentially creating a slide puzzle approach to architecture. We can move these pieces around because we know we have optimized subcomponents. So things started getting even crazier with looking at all the sub-design options. Logic, looked at some zero-touch stuff, Revit, layout, and then analysis of what direction these Revit families were going. I think that's it. Yes. Questions? Yes. Did you use refinery? No refinery. Every time we wanted to, we found a reason why we didn't have to. Because the bin packing algorithm actually allows batch runs. And then also we had Patrick over here who redid the node and created his own adaptation of a zero-touch node that actually ran, there's a slide back there, but it ran it across multiple bins at once. So you could have a catalog of 10 things and it would try to fit them across all 4 bins rather than batch running it each bin at a time and then assessing the score of those. That makes sense. So yeah, no need for refinery. It's very efficient. Unfortunately, that would have been fun.
Any other questions?
Thank you.
Okay. Thank you, Matt.
All right. So next we have bridge feasibility studies in not refinery.
Not refinery.
Yes.
So I guess we had similar problems to the guy had. Refinery in our case was not an efficient tool, unfortunately. And yeah, this is the name of our team. We decided not to be creative. Whatever. Okay, so traditional process of bridge design. So we have spans and piers. Span can be different types and each type can have different sizes. So the way it works in the industry right now, you basically select one, then you involve it one time, and then you involve it one more time, and you have 3 options to choose from. It is bad business practices, I guess, because if you have a lot of options to choose from, it's always better. To give you an idea of what a beam looks like, that's kind of some pictures those are actually families from Revit we modeled specifically for this hackathon. Okay, problem statement. To give you an idea of how many design options we could have is we have central span in the center. It's either 1 or 2. Then we have either 1 or 2 or 3 or 5 or 6 branches, branch spans. And then each of these can have different size and all of them can have different types. So that's 500,000 possible options in total. Initial plan was to take data about deck sizes from Excel, then using custom Python or whatever node to create visualization in Dynamo, then run Refinery on it and push it back to Revit to produce documentation. And so it was an initial problem, but when we tried to solve it, we found another one. So basically, we have 5 sliders for 5 different types of, for 5 different branch spans. However, we can have 1 or 2 or 3 or 5 spans in all possible scenarios. So if we have only 3, then sliders 4 and 5, they doesn't work because they're not connected to anything. So we try to find different solutions to this problem. So our assumption was if we will create basically an if statement in a Python node, it will let us turn sliders on and off. It is something that Refinery just ignores. So regardless of what your internal filters are, Refinery will always show you all possible variations for all sliders. Second problem. We decided to go even deeper, and there are actually filters we had to apply to solve this issue. So there is a certain length of the bridge we had to maintain. So obviously the bridge couldn't be just 2 shorter branch spans, and it couldn't be 10 longer branch spans. Okay. So unfortunately, again, there is no way to filter results in Dynamo. When you push it to Refinery, it will just take everything. And you may say that we could have filtered them once we get the results in Refinery, but the problem is that we had 500,000 possible design options, and well, if Refinery would process it, it would be a mess, but it didn't because it's just too many options. It didn't work. Yep. Okay, so what we came up with is that we decided to create our own version of Refinery, which is basically a loop and a loop and a loop, which has filters and results in the Excel file. We haven't done that yet because it is a complex task, I guess, for today hackathon. But we've done a second part of it where Dynamo takes an Excel file and then just throws whatever bridge into Revit. And that's about it. Any questions? Oh, actually, there's one more thing. We actually lost about 3 or 4 hours trying to solve one issue because of that small Python 2.7 thing. Because whoever started learning Python, like in the nearest past, and they probably started with 3.6, and there are some differences you need to take into consideration.
Cause the problems.
Yeah. Yeah. Now that's it. No questions. Thanks, everyone.
Did you get the 500,000 results out of your platform?
No, we didn't. But that's planned.
How many did you get?
We faked a spreadsheet.
Yeah.
Thank you.
Thank you, guys.
Hi. So yeah, we decided to do our project on balancing lot cut and fill. Fun fact, I didn't know what a cut and fill was before coming here. But yeah, so moving forward. So yeah, the general overview.
So the main part we were trying to look at was the fact that in filling lots with houses or different community dynamics, we end up with a situation where we want to try and optimize size, but keep enough green space in that essentially design of what you're doing for the space.
Yeah, so our goals and constraints for our optimization, we wanted to minimize the volume of cut and fill, maximize profit, and maximize greenery space. Some of the constraints were we initially wanted to create like a whole area with multiple lots and multiple houses, but we limited it to just analysis of a single lot, just based on time. So goal 1 was to balance cut and fill. So this kind of was an iterative process to complete this task. We initially wanted to integrate Civil 3D to do the cut and fill of the geometry, but we were having some problems with that. So then we switched to Revit, and then we encountered some more problems with that. These two could probably talk more about. And our final version was just generating that geometry all in Dynamo, and that's what we rolled with. Goal 2 was maximizing profit. So the way we determined that was we calculated the volume of the cut, the volume of the fill of just as like a single building, and multiplied that by the cost per cut, cost per fill. And we did the difference in volume, cut and fill, and calculate that volume and determine that cost. And that was balanced by the income based on the house's area. And the last goal was maximizing the green space. So this was just calculated by a ratio between the building area and the lot size area. So yeah, this is the overview of the workflow. We generated a surface with Dynamaps. We created a variable building size and variable building lot, which determined the impact ratio. And then we did the cut and fill calculation in Dynamo, and we used Refinery to optimize the building size, and we viewed those options. So this is our Dynamo script. And this is our results. Do you want to talk more about the results?
The main problem with the results is we actually didn't have a cost value for the houses that were being built, so that number then became straight as an example of that.
Yeah. So yeah, what we see here are just like a bunch of varied sizes of the houses. So we didn't have time to like really dig deep and analyze this. We like finished this script like just as presentation started. So economic and industry value. So economic value, this idea could help with like site grading using Dynamo, and it could create developer interest. Some industry values, it saves time finding an optimal design with these like qualitative goals. So lessons learned, we definitely learned about like scoping out your work for a hackathon. We just kind of threw out a lot of ideas for maybe we can integrate like different size geometry per houses or adding trees and things like that. Another problem was we had problems with getting Civil 3D to work, and we really tried to get that to connect to Dynamo. And also Revit we had some challenges doing that process. And that was our work distribution. I think that's it. Yeah. Sweet.
All right, everybody, I've been paid to entertain here tonight. So please clap. Come back over. I'm going to show you a couple things from, this is a presentation that Radu and I just did last week over in Seattle, and I'm going to do a very abbreviated version of it. So the fun part about this presentation was that the presentation started at 9, it was over at 10:15, and I had a flight at 11, and it worked. And I got on the flight and I got back. Anyway, the idea with this presentation was just to go over some of the sort of the broader ideas that are involved in generative design and addressing sort of the hullabaloo and some of the hype that is around generative design and how things go with that. Also, by the way, my name's Zach Crone. I'm a product line manager over at Autodesk. So you can blame me for all sorts of problems that you might run into over the last 2 days in your following lives. Sorry, and you're welcome. This was us. The session description, I'll flip over that. So for those of you who have the t-shirts, you might recognize that initial view. So I'm just going to back up there for a second. Stop. Okay. Well, did anybody notice the initial sort of graphic that was in there? Does everybody have a t-shirt from this thing? Nobody's wearing the t-shirts. Can somebody stand up and model the t-shirt? All right. Does everybody see the Simon is modeling a lovely t-shirt? See? Now, does anybody know what the story is of the infill pattern in this shirt?
You're going to tell us.
I am going to tell you. So that t-shirt is the algorithm that was used to generate the interior layout upstairs. It's the algorithm redeployed instead of inside of the floor plan of this building. It was redeployed inside of the words for Dynamo in the back of the shirt. Anyway, it's a little complicated, makes a nice pattern. We reused it. The reason I use this graphic, just to sort of start off talking about this, is that we've used these graphics a lot in talking about generative design, and it kind of gets people excited, and it's kind of interesting. It doesn't really help people get started actually doing generative design. And there's a couple of things over here on the left side of the screen which actually do help you get started, which is this idea of generate, evaluate, and evolve, also an Explorer. But these sort of more simple concepts are sort of the things that sort of happen in lots and lots of ways of doing generative design. I'm going to talk a little bit more about those. And the way that this thing breaks down is that if you leave with nothing else from this short and abbreviated talk, is that there's a couple of 3-step processes that you can repeat, not just in generative design for architecture, but also for things like organizing all sorts of projects. And they all start with the idea that there's an idea. There's some reason that you're doing a project. And the way that you can execute on ideas is generally, there's sort of 2 broad methods. One is you can get a lot of people involved, and you can sort of brute force your way through it with lots of people. The other way is that you can look at automating these processes. And finally, there is some method by which you tell whether or not you've done a good job at it. Most people have been working in this sort of mindset for the last couple of days. And the way that we generally talk about these things is that there's goals, there's things that generate ideas or solution spaces, and then there's methods to evaluate those outcomes, which is the why, how, and what of accomplishing these projects. So I want to show a couple of things that are sort of precedents for this way of thinking and this way of doing jobs that kind of take it out of the realm of, oh, we are groundbreaking in the discipline and in the world on doing generative design. Just to say that there are things that happened before any of us, that we're standing on the shoulders of these giants. This is an image from Nervous Systems. They used to be Somerville based, they're moved outside now, from Massachusetts, from my hometown. And these are designs that they've made for years and years and years using generative systems to create things like lamps, jewelry, all sorts of amazing things. I'm also going to talk about some of the other precedents for this, how we think about technology and its adoption. Anybody here know the Gartner Hype Life Cycle? You seen this before? I always love this one. And we're also going to look at some precedents from some very, very, very exciting adjacent businesses like business management processes.
It's time.
Is this better? Maybe? We'll see how far I can get with this one. So I'm going to do this thing that everybody hates, but I'm going to do it anyway, which is maybe how many people hate this question? Anybody? I hate this question because I get this a lot. Like I get it a lot where people come in and they say, can you tell us about what generative design is? And I always have to sort of understand what it is that people are asking about. Because generally it's sort of from two different places. One is they are people who are trying to actually implement some solutions because they have an idea of what they want to get done. And so it's sort of a tactical question. It's like, how do I do this thing? And then the other one is strategic. It's like, what does it mean to my business? What does it mean to the profession? What does it mean to how we make money? And those are two different questions and they're two different sort of approaches. I'm going to talk sort of more on the level of higher level ideas of like, what are its precedents? And part of the way that you can answer that question of what is generative design is to talk about what generative systems are. Generative systems are things that are, I think, a little less controversial and a little less sort of territorial in terms of people claiming that they're doing it or they're not doing it. In general, generative systems are sort of a well-established idea. And I'm going to characterize it very broadly, that you sort of have a structured organization that you can set in motion that results in a set of interesting and surprisingly complex objects. And the reason that we're interested in them is that they can be surprising, but also that they can solve these sort of tricky problems in ways that we might not have thought about. Sorry, I don't have any notes with this, so I'm making this up on the fly, if you can feel me on this. So generative systems, I like to do this little exercise with people. If you have a piece of paper, you can draw along. Gentleman in the front. So for making generative systems, there's a lot of discussion about, oh, it's not generative unless you're doing it on the cloud. Or it's not generative unless you're using our software or whatnot. I'm going to do a generative system right now. I'm going to draw a line. I'm going to now draw another 2 lines branched off at the end. I'm now going to repeat that until I get bored. So that's a generative system. And I didn't use a cloud-based anything. I didn't use any kind of machinery at all. Just to illustrate that the idea that GIFs are unreliable, but also that the idea of doing generative systems is independent of all the technology that we might throw at it. This is a GIF that was making a lovely tree and variations on it. We'll see if this one runs, but maybe not. Oh, yeah, here we go. This is one of my favorite generative artists. Her name is Amy Smith. Get her on Patreon, send her your money. She does these absolutely bananas generative design projects where she will come up with a rules-based system and a way to execute them, and then she will sit down and draw like hell. And every time she does it, it comes up with something different, but the rule system that's executing it is the same. And just to sort of identify that these are methods that have preceded all of the technology that we're building. There's more about sort of a mindset. This mindset goes back pretty far. This is Verna Molnar. Sorry, I think I'm getting the name right because I'm not seeing my notes, but she was a Hungarian-born artist who in the 40s was doing generative art by hand, doing these paintings that were basically based on theme and variation. She would come up with a system that she would continually execute and try out different ideas. by the sort of the late 60s, she started automating and reproducing these things, writing them in Fortran. She continues to work right up until fairly recently. She still had some other exhibits. Manfred Mann was working around the same time. Another guy who was working in Fortran and looking at how can we start exploring the ideas of language and language reproduction in both a graphical and a three-dimensional way. So he was sort of adding in this idea of how do we start looking at three-dimensional form and reproducing this sort of form and variation. This then got followed pretty close on in the early 1970s with folks that were looking at shape grammars. George Steiny and a group of folks over at MIT, also folks like Terry Knight, started sort of doing this sort of maybe one of the first sort of formal entry points into architecture using generative systems as a way to look at form and problem solving within the architectural space. A lot of that thought back in the early 70s still forms the sort of the underlying set of algorithms that we use in things like City Engine or other tools that are used for automatically generating urban form. So all of those generative systems and their lead into, well, is there a meaningful distinction to make between when you have generative systems or you're doing generative design? Well, at the basis of when we're doing generative design, we're still talking about a couple of sort of basic things. We've got a rule system, generally it's coupled with iteration. Sometimes it has a goal, not always. As we can see from some of these systems, there might not be a goal. It might be purely exploration, where you're going to take these rule systems and you're going to start executing them and see what happens. Often and not always, they have an analysis and a metrics sort of associated with them. So you can make all sorts of arguments about how one thing is better as a generative system than another, about whether or not you're going to have it attached to metrics or whatnot, but that doesn't make it necessarily a generative system. But I think everybody pretty much agrees that it's a process, it's not a software. And this is just a diagram that sort of says, sort of within this bubble, there's lots of different systems that people can execute within a generative design system. Which gets into sort of products and product strategies. So generative design is really a strategy that we are looking at and employing at Autodesk. And I see it as sort of that there's sort of three pieces to it. The first is that all of these things need, as we saw with systems, that they establish a set of rules that express some kind of design intent. That could be some amount of algorithms, it could be coupled with some amount of drawing process, but there is a set of rules that's involved. For our process and for our strategy, it becomes most meaningful when we also couple it with a display system, so that you can actually say, I have a system which is generating many kinds of options. It is most useful when I can actually have a systematic way to go through and inspect what those outcomes are. And finally, again, back to the sort of the practicality of generative design as a sort of a product strategy and a product approach, is to say, can we take the decision-making that is enabled by the display systems and drive it back into tools that are part of our production pipeline? So is this, can I take the ideas that are generated and drive them into something like Fusion? Can I drive them into Revit? Can I drive them into Civil 3D? Or some kind of tool that is part of my project delivery mechanism? So how that breaks down for something like generative design in Refinery is there's two rule systems that are basically at work in Refinery. There's the directed acyclic graph, which is the fancy name for node and wire diagramming. Anybody ever heard directed acyclic graph before? Yes, thank you. I always love like the sort of the fancy names that go around. Is directed means that it goes in one direction. Acyclic means it doesn't go back to the start. Directed acyclic graph. No, you can impress your friends by calling it a DAG. So Refinery is able to feed on these graphs that come from Dynamo. We'd like to expand it to have other things that can be feeding into it in the future. It has evolutionary solvers that are part of that process, so it's another piece, another systematic sort of execution that's happening in it, where you're feeding in this graph, And Refinery is now saying, okay, I'm going to keep executing. I'm going to keep looking at the outcomes of it. I'm going to keep feeding that sort of outcome back into the results so that I can get better and better results. And we're also starting to supply a toolkit of pieces for solving common problems. Like people very often want to solve things like, what's the shortest path between A and B? How can I start jamming a lot of objects into one single space? As we saw from, what was the group called? Pinception was trying to sort of develop that a little bit farther too. And it's set up so that you can layer on more and more tools going forward in the future. You can look at tools like Fusion and the generative design tools that are in Fusion in the same way. So what are the rules-based systems? What are the display systems? So Fusion basically has a couple of different, actually several different hard-coded solvers. It does some topological optimization. It looks at how to optimize for things like additive 3D printing so that you have the most efficient layout for it. They are also doing analysis on things like strength and bending, and they are also adding in a couple of other solvers as they go forward in the future. So all of these systems are sort of based around, there's some starter toolkit for the solvers that you have, and there's some amount of way that you can expand that in the future. And all of these systems that we're talking about, I mean, I can at least just talk about the Fusion ones and the ones in Refinery, is that there's a built-in display system. So we find that to be an essential aspect of what we're doing. And I think that we also saw several projects that were looking at expanding the ways of display. So as people start to experience more and more of these sorts of generative design projects within the architectural or the manufacturing context, it becomes more and more evident that it is important for us to have some way of understanding large design spaces and narrowing them down into things that you can actually make decisions on. And then the idea of capture, and it's one thing to sort of make a drawing on a whiteboard or do a set of generative designs that are, you know, spewing out very interesting things that you can make decisions on, but unless you're actually taking it and driving it forward into your project delivery system, we think that it isn't as effective. And what we really want to do is we want to take these technologies and enable people to actually build more interesting, thoughtful, performant things in the world. And in order to do that, there's a whole tool chain that people are already using that we want to become a part of. All right, well, so much for that. The heart of the approach that we've been talking about is this idea of definition of goals, how do you generate solutions within that space, and then how do you evaluate them? We have larger graphs which also get into other pieces of that. How do you evolve? How do you explore? How do you integrate those things back into what you're doing? But I'm gonna meditate a little bit more on the goals generators and evaluators here for a second. I'm gonna break it down really basically into, this is what you do in generative design and refinery. There's specific stuff that I want. Computers can make lots of stuff, and we're going to manage the process. And the reason that I just sort of keep reiterating this is that this is the same process that shows up in other things. It's not just for our design process. And I think you guys have all looked at this one, so I'm not even going to get into that one. But I want to jump ahead to, did everybody see 3-box at some point? Did you guys talk about it? I'm going to guess everybody looks stunned here, by the way. You're like so tired. It's like, whatever. Is the beer good at least? All right, so 3-box has been this, it's like the simplest generative graph we could think of to feed into Refinery. And the basic pieces of this are, you got your generator, you got your evaluator, and you got your goal, which is seen off screen. And the way that this goes is that we've got a tool that makes 3 boxes, and it moves them around in X, Y, Z coordinate space, and it makes them taller and shorter. That is the way that you make variety. There's no intelligence to that piece of it of saying whether one is better or worse. Where you get into where one is better or worse is in the analysis section. There's 2 little nodes that basically measure what is the area of these buildings on the exterior and how much volume do they have. That's it. And the goals are something that is off screen. It's basically the question of, why am I doing this in the first place? And this process is something that, hold on. Oh no. Sorry, like I said, this is part of a larger conversation that I want to jump out of. Good Lord. All right. I'm giving away my stuff here. All right. So if we take it with the idea that there are goals and generators and evaluators, and I think that everybody here sort of did touch on goals, generators, and evaluators to some degree on most of their projects here today. There are parallels to these ways of working that exist in other industries. We could really get depressed quickly by doing a comparison between the state of generative design technologies in things like gaming versus where they are in the architectural practices. This is a shot from 2014 with a game called No Man's Sky. Anybody heard about No Man's Sky or a player of it? Well, we got a few players of No Man's Sky. Anybody like it? Do people are you enjoying it? Someone? Good. I haven't played it myself. I've just sort of seen the videos of it and seen the making of. It's amazing. It's got 18 quintillion planets, which is like more zeros than anybody needs. But the idea of this is it's a world building. It is 18 quintillion planets that you can go and visit and see all of the varieties of what different planets could be. They make spaceships, they make animals, they make plants, and the whole bit. It's not just spewing out random variations of plants and animals and spaceships. They're all gold around certain kinds of resonance that the plants and the animals and the spaceships have with these different planets. So for instance, this is one of the planets that is it is a wet planet. It is reddish. It is, you know, swampy. And the animals that are more appropriate for this environment are created in such a way that they have a resonance with that. So it's not just generating 18 quintillion planets. It's evaluating them based on a certain appropriateness to their own configuration. So much for gaming. There's a lot of things that you can do for gaming and generative work. The recent Spider-Man, where they make the entire Manhattan with all sorts of detail, is just amazing. But there's two older approaches. One is workforce management and large project execution. And the other one is farming. Anybody who knows me knows that I like pumpkins, so we're going to talk a little bit about pumpkin generation. So generative design and farming, there's specific stuff I want. I want a pumpkin. Nature makes lots of stuff. You can just let nature go and it'll start spewing plant material out into the world. But maybe you want to manage that process and there's specific kinds of pumpkins that you want. And let's see if we get audio here too. Maybe. Yes. We are going to see the generative design process in action in farming.
And the Halloween season, like pumpkins and pumpkins. A front door step or porch decorated with these autumn favorites is a symbolic of the fall season as green bar of Christmas. They're fun, and children alike. To plant, direct to the seeds right in the garden soil in early summer after the ground cools sufficiently. For planting both pumpkin seeds and gourd seeds, the technique is the same. To start, create a mound of garden soil raised 2 to 3 inches above the ground soil level. Make sure that the mound is free of debris and weeds. Create a small furrow in the top of the mound and place 2 to 3 seeds of each your pumpkin or your gourd. Plant your seeds about 1/4 of an inch deep in the mound and cover over with light fine soil. Gently water in to settle the soil around the seeds and begin the germination process.
All right, so everybody gets the generator.
10 days, you'll see your
This is the generation process. Seed, soil, sun.
1 to 2 inches, you can go ahead and thin out the weaker seedlings, either your 1 to 2 strongest seedlings to grow. Remember to keep your plants well watered during the growing season and don't
I could have edited this, but we're getting to evaluators in a second.
as the vines continue to grow
Metrics.
and to keep the area weed. One of the questions I get asked most about growing pumpkins is, how do I know when to harvest?
How do I know if I have a good pumpkin?
First, you observe the coloring on your pumpkin.
Color.
Nice, deep, rich orange color. Next, you see that the stem isn't soft to the touch anymore and gets really hard and resilient. And here's the most fun to observe part of the plant. Each pumpkin has a tendril at the spot where the stem meets the main vine of the plant. When this tendril goes from green to brown and dry, then your pumpkin is ready to harvest.
All right, so does everybody see now how we can evaluate this? Goal, I want a pumpkin. How you decide that that is something that you want, up to you, your personal preferences. The fact that pumpkins are the expression of perfection in form is just not widely understood. How do you generate them? You get seed, soil, and sun. Straightforward. And if you were to just sort of cast those out into the world, you would get a bunch of garbage pumpkins. But some of them would be good. Evaluators, that's pretty good. You can evaluate it on color. That is a numerically evaluatable thing. Do I have an orange pumpkin? Again, I'm missing my notes. There's something called a penetrometer, which will actually quantify for you whether or not your pumpkin is firm enough. Anybody's looking for a Hanukkah present for me. And finally, the dry tendril, which I never knew until I saw this video, that is a Boolean function that you can just put in there to sort of say true, not. Okay, moving on. Business process management. There's specific stuff that I want. People make lots of stuff. We have methods to manage the people. Those people management processes have evolved over time. There are more draconian, more gentle and humanitarian methods. I'm going to talk a little bit about more humanitarian methods. In the 1960s, shoot, I want my notes. I might just open up something. 1960s, Peter Drucker started messing around with these ideas of management by objectives. This idea that you can basically break down large projects into small bite-sized pieces and evaluate how they go along the way. It was, what's that? This is off the online one, and it doesn't work the same way. If you can, great. I'll try. So the interesting thing about management by objectives was it basically was an evolution of this sort of Fordist idea of, so Henry Ford made the idea of we can break a car down into smaller pieces. And each one of those smaller pieces can be created by a person who is focused on just making that piece. And if we sequence it all out, all of those pieces can be assembled in turn and then made into one full vehicle. So Peter Drucker comes along and he says, we can do that with sort of the work that happens in offices, the larger goals that happen through corporations. We can also do it where we start to acknowledge that people need to have a sense of fulfillment and a sense of well-being and a sense of having contributed to things. And how do we start breaking down those ideas into that sort of approach? Because it's not going to work.
No.
Yeah.
Tried.
Yeah, it's okay.
Here, right.
We'll see how much I remember.
6.
View from current. So much for Peter Drucker. He started popularizing this idea in a lot of corporate environments where people started imposing these ideas of saying, how do we start taking the larger projects that our corporation is going to try and achieve and think about it as pieces that we can divvy out to different people within the group. There's all sorts of variations of those things, smart objectives. Any Silicon Valley watchers here can join triangles of success. So all of these different management frameworks, we had objectives and key results, SMART goals, balanced scorecard. These can be a little stupefying sometimes, but they get shit done. And that is the point of all of these systems. I want to talk a little bit about objectives and key results. Anybody in their company use objectives and key results? A couple, yes. So this is, I'm gonna ship my company out to you now in our software. So objectives and key results is a variation of this sort of management practice. And it was first used in Intel, I think in the early 90s, and then Sergey Brin and the rest of the folks over at Google got really excited about this sort of management method of saying, there are ways that we can take large organizations and we can say, we all want to row together to build the same thing. So how can we all get together and build the same thing together? And it's pretty simple. It starts with this idea that we have an objective. It is our big idea. We have key results. We have people who can do this work. The thing that's hidden in OKRIs, of objectives and key results, is that it's also OKRIs, which is initiatives. So we have our big idea, we have our objectives. We have initiatives, which are things that we're going to do to get closer to our objectives. And we are going to evaluate those things to get shit done. So here's one more video that is, I'll skip around on this one a little bit.
Now that we've seen where the OKR framework is coming from and the value it will bring to your organization, let's have a closer look at the anatomy of an OKR. The objective tells you where to go. Objectives are statements that inspire and set direction. Now, key results answer the question, how do I know I'm getting there? They help you specify what you mean by the objective, and they help you measure progress towards it. Now, initiatives answer the question, what will I do to get there? Initiatives are all the work that you put in order to drive progress on your key results. OKRs and initiatives help you differentiate between outcomes and outputs. Organizations usually buzz with activity, but which outcomes is all that activity intended to achieve? Imagine you're a surgeon and you perform a technically flawless surgery. That will be an output. If the outcome still was that the patient died, would you consider yourself successful? Your OKRs are your outcomes, and your initiatives are your outputs. Now let's have a look at a few examples of good OKRs and initiatives. A good objective could be to conquer the US market, or to become an awesome place to work. Another good objective could be to make our customers love our support team. If we zoom in on the latter example, examples of key results could be a customer satisfaction score of 97%, an average first response time of 1 hour, and an average solution time of 12 hours. Now, initiatives that you could have to realize that OKR could be to interview 10 support web candidates to help you bring down your average response time, for instance, to publish an FAQ to make sure that you get in fewer tickets and people can find answers to their most popular questions themselves, as well as to launch an in-app live chat, which will make it a lot easier for people to connect with your support team. A bad objective would be to triple our valuation price. An objective should not be measurable. You'll often read that an objective should not contain a number, and then people try to hide the number in the word triple, which obviously means nothing else as times 3. Better than focusing on not adding a number to your objective will be to make sure that your objective is simply not measurable. A bad key result will be to close tons of new accounts, because key results have to be measurable, and tons of isn't. People will have different definitions of what tons of really means, which means that you have no clarity of expectation. Capture 100% market share is also a bad key result. Key results can be ambitious, but they should not be impossible. And 100% market share for most organizations is definitely impossible and can therefore be demotivating. A good objective would be to make so much revenue that we vastly increase our valuation. Now the objective isn't measurable, but it is inspiring. A good key result will be to close 85 new accounts, because now you can actually measure progress towards it. And capture 30% market share would also be a good key result, because this is probably ambitious, but hopefully not impossible. Now that you know how to structure an OKR and what a good OKR looks like, let's have a look at how OKR works when you roll it out in your organization. We recommend you to always start.
We'll call that enough. So everybody feel like they understand what an OKR is now? Can anybody see a relationship between OKRs and how generative design might work? All right, I'll break it out a little bit. If we take our same sort of 3-box project that had generators and evaluators and things that we've been sort of recognized within Refinery, the objective is the big idea again. And you could say things like, the objective is I want a building that doesn't cost a whole lot and can fit a whole lot of people. Key results would be having a building that has very little exterior envelope and a whole lot of interior volume. And the initiatives that you could do in order to build this building is you could take a whole bunch of people and you could put them on the project of making the building, or you can start mechanizing the process with some amount of algorithms. Or you can use both in combination with each other. So again, back to our 3-box problem, we've got initiatives and we've got key results, and your big idea and your objective is something that happens off screen. It's why you're doing the project in the first place. So, so much for goals, generators, evaluators. The interesting thing also about these goals is that goals and generators and evaluators can all be separate. They all can be things that sort of exist in their own space and time without necessarily being associated with each other. I like the projects of Boulay because his projects really represent goals. I want a big, impressive, monumental building. I have no idea how to get there, but it's an impressive, inspiring way to sort of demonstrate an idea. Things like flying cars and jetpacks are also goals, but they are disconnected. They are inspiring, but there isn't necessarily anything that is going to help you get to that spot. Generators, similarly, you can say Johnny Appleseed was a generator. He went around with a handful of seeds and walked around and threw them everywhere and just made apples all over the place. It was not necessarily gold on anything. It was a lot of fun, but it may not have accomplished anything. Same thing with other things like, and I'm going to have GIF fail again. This is my spirograph. Spirographs are fun. They generate a lot of ideas. They can be very compelling, but they don't necessarily get anything done. And my favorite one for evaluators is if you have evaluators without any other context. So those two guys are the ultimate in disconnected evaluators. If you have something that is measuring something that you have no real reason to, or that is not connected to your goals, it's just whining. So I think, well, I could turn this over to you. You want to walk through any of this? Or? What's that? I don't know if I can talk through this stuff. I'm actually going to leave this now. If folks want to grab another quick drink, I'm going to see how we're coming on judging. And we'll be right back.
Hi guys, we're back. If you guys could come forward, we have winners.
Woo! Yeah. Yeah. Get excited. It's Friday.
Good.
Yeah. Are we still recording?
I do not know.
Hey Ellen, are we still recording or no? We are? Oh, hi guys, we are back and live. You want a second?
Don't worry about it, it's good. It's good. It's fine. It's fine.
Is there a second mic?
Thanks, Simon.
Cool. Second MC of the house.
Hello.
You're not going to stop showing off your inbox.
Oh, sorry.
Just not for your own.
It's just a whole bunch of Scott Mitchells.
Scott's been busy.
Yeah, Scott's been busy.
He's been working hard.
All right. I don't think I'm sharing, just to the room.
No, just the camera.
Okay.
Cool. All right. Thank you guys again for joining us. We really love seeing all your presentations. It was a hard deliberation, and we made a last-minute decision here. So
we did.
We hope that everybody is happy with the outcome. We were really happy to see what you guys all did. Did you guys have fun?
Yeah.
Yeah?
Hey!
Yeah, great.
Shout out to you guys.
Yeah, so great. Did you guys learn a lot? Yeah? You have a bunch of great people that you can talk to afterwards? Make some friends? So great. Hopefully you can reach out to us, you can reach out to your new buddies here, and we have a good time. Thank you guys for coming out to Toronto, especially the ones that flew all the way from London or Austria or wherever you guys came from. Germany?
Uruguay.
Germany? Oh, Netherlands, sorry. Confused. Uruguay, yes. Thank you guys so much. It's been a really great few days, and hope you've learned a lot about Dynamo and Refinery. And like I said, if you guys need anything, we're always available to help. We're easy to find on Twitter, via email, anything. Enough of that. So we have a few spot prizes we'd like to give away before we get to the main prizes. The first one is for most persistent in positivity. So we Saul's a spiritual gangster. I'm very into yoga. We're very into positivity. So we'd like to congratulate this team, Hammer Slammers. Hey.
Come get your wings. Come get your wings.
We take a picture. Come up here. My favorite. We're gonna take
Come
a
on,
picture.
Hammer Slammers.
Your favorite. Yeah.
We have a dedicated photographer.
All right, congratulations, guys.
Congratulations.
Great job.
One month together now. Experts. Awesome.
All right. Our second spot prize goes to the most curious team.
The team who asked the most questions.
Yeah, team who asked the most questions. Yes. And that goes to Forms and Forces.
Come on up and get your part.
We got you chocolate.
It's only mine.
Yes.
We only ask questions because I like you so much.
Let's take a picture.
The whole house is on. Hope it doesn't help.
Cool. Round of applause.
Thank you, guys. So here we are.
It was our deliberation.
All right. So our deliberation was around how many people were going to get third because we had a tie. And we were like, should we try to do some weird things, weird calculations?
So we tried to do, well, first of all, the points added up to exactly the same tally, very close, obviously. And we then tried to do the median. It was within 1 point, so we thought it was unfair to give it to one team as opposed to two. So in a dual third place, starting with one of the teams, no particular order, we have Pinception. One of those. Come take a photo.
We really enjoyed your, maybe you inceptioned us early on, I'm not really sure. Did you plant a seed in our brain to pick you? I don't know.
Thanks, guys. Round of applause for Pinception. And then we have our second third place team. So could we please give it up for Blackball? The funniest presentation of the day.
Yeah, we wanted to get another spot prize for funniest.
But
You
you're
guys were
winning,
great,
so.
but congratulations.
Yeah.
Yeah, you guys had a fourth member. Yeah.
Yeah, Mike.
We ended MDMA.
We're in the shirt line.
There we go. So congratulations to Blackball. MDMA third,
Right. Second prize, also quite funny.
also quite fun.
Also quite funny. We love these guys. All the way out from Europe. Give it up for Trainwreck.
Hey! Sorry, Lawrence, you don't get a double in first place.
Congratulations, guys.
So congratulations.
We need to get a little bit of a drum roll, maybe.
Yeah, can we get a room-wide
Yeah.
drum roll, please?
Yeah, okay. And in first place.
In first place, we have Team Surat. So please come on up. Oh, yeah.
Wait, I think I gave an extra one to somebody. Did you get 4? Okay, one of them is there.
We have the champions in the room now. In good company with the Raptors, I see.
What if you guys got a picture one? It will have Simon's face on it. Okay. Did you guys have? Oh, yes. Here we go. Thank you. Yay. All right.
So everybody make your face on it as well. Enjoy. Congratulations. Round of applause.
And once again, thank you guys so much for coming out. We'd love to chat with you a little bit more throughout the night. We're here until 7. So thank you guys for all your hard work. I hope you enjoyed it. And hope to see you soon.
And drinks up the back, some snacks at the back of the room. Let's mingle. Let's chat. Let's enjoy some non-Dynamo stuff for a sec.
Well, we'll put on some other music that's not that
Hypey
like,
music.
weird house music. Oh, what? What's right in the presentation? Oh, there's more? Oh, and a big shout out to the Tech Center team who provided this space for us. Ellen especially, who's at the back. Thank you so much for donating the space.
Thanks, Ellen.
We've had a really great time here. And thank you guys for making such a great event.
And enjoy the fresh air for the weekend.